Right. Hello, everyone, and welcome to today's webinar. We have a very exciting and interactive session planned for today, where we will talk through the latest innovations to come out of Splunk Observability. Now, before we begin, please note that irrespective of what you hear today, our lawyers tell me that I have to tell you that you should be making your buying decisions based on what Splunk offers today. And so with that out of the way, let's go ahead and introduce our speakers today. So I'm Patrick Lin. I'm the VP of Products for the Observability team at Splunk, and I've been in this space nearing a decade, and prior to that, the bulk of my career has been in platform technologies that help ensure that apps and infrastructure are as resilient as possible. I'm joined by Billy Hoffman, Senior Principal Engineer, and Billy was previously the CTO of Rigor, a leading synthetics monitoring player acquired by Splunk. He also has one of the more entertaining LinkedIn bios I've seen, where he describes the grades he got while attending Georgia Tech with just one word: variable. After Billy, we'll have Zongjie Diao, otherwise known as Z. Z is the Senior Director of PM, leading the teams responsible for infrastructure monitoring and IT service intelligence, two of our flagship offerings in the Splunk observability portfolio. And her background also includes stints at McKinsey and Cisco, where she led efforts related to AI, ML, and new product incubation. And finally, we have Gio. Gio's been working at Splunk for about 7 years, helping customers adopt and use Splunk products, with roles ranging from professional services to tech marketing, ML research, and now product management. And he joined the Incident Intelligence project last year and worked with the team to GA that capability this past February. All right, so with that, let's go ahead and get started. I'll be covering an overview of how we enable higher levels of digital resilience using observability, and then the rest of the team will get into the details and demos, more excitingly, for the latest updates. And we'll wrap it up with some Q&A, but feel free to inject questions into the Q&A box as we go along. Let's talk first about digital resilience and the role that observability plays in helping to drive improvements to it, right? And to set the stage, let me take you all to a mental place where you probably don't want to be, or might be right now, even though you're listening to this webinar, which is being on call, right? Now, those of you who have been on call will find this sort of question to be a familiar one. And I have to say, I experienced it myself a number of years back when we first launched our cloud native metrics offering and started to see some spikes in the request rates of some of the microservices that are part of that offering. And when that happens, it was kind of hard to tell why it's happening, right? Is it because the code that got pushed that day? Is there sufficient capacity in the compute that we provisioned to handle the incoming load? Could there potentially be a bad actor involved somehow? Or in our case, luckily, it was just a massive amount of interest in the launch, and it was legit traffic, right? But it's hard to tell in the moment. And when you sort of generalize that kind of incident, that kind of experience to the context of larger organization, and think about how it needs to respond, turns out there's a lot of functions that need to be involved, right? Engineering, of course, when you're doing those sort of pushes, but then also infrastructure and ops commonly, right, with the IT crew, and then security as well. And so I think the argument I'd make is that you need to have the capabilities that help each of those parties understand what's going on, right? To have that visibility, to be able to figure out what's going on in an incident, to be able to accelerate the troubleshooting, and then hopefully also do it in as a streamlined and automated a fashion as possible, right? Because sometimes these things, unfortunately, are repeat, and you don't want to have to reinvent the wheel every single time you have that kind of issue, right? And so at Splunk, what we've done is built a very integrated capability for doing this that we call the Observability Cloud. And it builds on top of a platform that natively ingests and stores and analyzes metrics, logs, and traces, and then provides out-of-the-box applications on top of that to provide visibility into your applications, your infrastructure, and your end-user experience as well. Now, some of you may be relatively new to this, so I hope we get a chance to engage more. But what I want to do now is pivot towards the focus of today, which is the new enhancements. And they're grouped into roughly two buckets, right? The first is about ensuring that you have visibility into what matters. This has been a theme of ours for a long time, and we continue to expand on it. And so we'll be talking first about how you get access to and analytics across all of the trace data from your applications to enhance your ability to find that needle in the haystack. And then we'll spend some time digging into a new capability in our metrics platform, which helps you filter or aggregate metrics at the front door of our service so that you can ensure that what gets retained is the data that matters most. And then the second bucket here is around incident response and on-call, which in almost all cases today, I think is a separate offering from your observability tools, right? And we're here to talk about how that can be integrated into the monitoring and troubleshooting workflows, how that can really accelerate your ability to figure out what's going on. Okay. All right. Now, with that, let me hand it over to Billy Hoffman. Billy?
Great. Thank you, Patrick. Let me go ahead and get things off. So we're going to be talking about traces and trace analyzer. And before I dive into that, I think it's really important, especially given how many sort of Splunk core users we have on the call, to sort of level set on traces and how organizations tend to use traces. I think a really great place to get started would just be like, wait, what is a trace? So you can kind of think of a trace as like the connective tissue between logs. So let's say you have a complicated backend or just a backend with multiple services. So maybe you have an API endpoint, you have a mobile app that's making calls to a backend API. There's probably a load balancer. That backend API is maybe talking to some data storage tiers. Maybe it's contacting additional internal or even external APIs. So someone on the mobile app contacting the API endpoint, it's going to sort of ripple a series of actions through your entire backend. And if you're logging into Splunk Core, all that information is presumably going into Splunk logs. Often what you want to do, though, is sort of have, it's almost like a join. If you're thinking about like if every log almost is like a SQL table and you're wanting to join those together to understand, hey, is this rippled through everything? What got touched? And let me sort of join my logs together so I have a concentrated view of what happened. That's what we're doing with traces. And we'll actually dive into this a little bit more when I do the demo. But what we're showing today is that we're, with our new trace analyzer, we're making it possible for you to see more of these traces, understand how data is moving through your system, when there is an error or there is a latency or a slowdown issue, how you can sort of pivot point, dive in and understand what that is, and then also find cohorts. So if you do detect something that is a problem, is this an isolated incident? Was this just Roberta had a problem accessing this particular service? Or did Geo or Z or PCL, did all these people have problems? And there's something more systemic here. So gaining that transparency and being able to sort of understand what's going on, that's really what we're going to be diving into. The reason people would use traces, and specifically what you can use trace analyzer, is when you're wanting to see sort of a lot of ways my system behaved for a large period of time. I'm sort of proactively hunting for where there's bugs or slowdowns. It also can be used in a triage process when you've detected a problem, and now you're wanting to say, okay, for a given trace, let me see some of the values, some of the sort of structured metadata that you're probably writing out into logs. Those can get extracted out and viewed alongside the traces. Often you want to see how those tag values kind of correlate with an error rate. So, wow, this particular service that we just deployed, it's having a lot of errors. Let's go look at our tags. Oh, this is I don't know, an insurance, a policy lookup system. Wow, this particular insurance class, that seems to be highly correlated with error rates. Maybe there's an undefined enum or something like that. And then also, if you're looking at errors and you want to kind of find related traces that maybe show what it's supposed to do, all of those are use cases for when you want to dive into traces and explore. So the best way to show is to show. So let me show and not talk. So I'm going to go ahead and select this and let me come over here. And I'm going to share this APM. Great. Everybody can see my APM screen. So this is our traces view is inside of our application performance management part of the observability suite. And so what APM does is you are deploying agents into your application, whether that's a classic, J2EE app, whether that's a .NET app, a Node app, what have you. It's, your backend application tiers and services. And we're going to collect information and help you identify where errors are. And often what happens is that someone, remember how we talked about that connective tissue that a trace is? Someone will say, hey, we just got a contact from support. Roberta was trying to use the system and it failed. And in the error message that the user got, it said, here's this trace ID to give to support. And what that trace ID does, we kind of talked about those disparate services. Here's the service map. A trace ID kind of says, hey, the logs that the checkout service is generating, the logs that the payment service is generating, and the logs that this peak-based service is generating, how do we unify and join those together? The trace ID is that connective tissue. And so often what happens is that you're given a trace ID, and you just sort of start there. We had an error, Roberta tried to do something and it failed. And so we can see that this is actually touching lots of different services. It starts at the front end where the user actually was making a HTTP request. In fact, they were making a post request to an endpoint. They got a 200, but there actually was an error. As we go down, we're starting to get to a checkout service. We're actually going to be accessing, this is like a RPC, a remote procedure call. It's actually going through a Go library. Ultimately, we're contacting to a shipping service, a checkout service. All of these are those services that are rippling through in the back end. And what we can see here is that actually we ended up getting an error message, an invalid request in this Go service. And if we actually drill all the way down, we find out that this was an invalid request from this particular backend API service. That's ultimately what failed when Roberta tried to check out and ultimately got her error message. So this is the trace, and it showed us that there was a problem. Now, Roberta happened to be the person that wanted to contact support and actually figure this out, or maybe Roberta was an internal QA person and detected this. But now you know that there's a bug. So what you're trying to figure out now is this an isolated incident, or is this persistent, and how prevalent is it? And so this is where you can come and start to say, let me go look for more traces. So what we do is we have our trace analyzer features. So if you come over here to the main page of APM, you can start looking at other traces. And what's really cool about Trace Analyzer is that we are, Splunk's approach to tracing is that it's full fidelity capturing, no sampling. So once you've instrumented your system, much like you've instrumented your system to collect logs, it also can collect traces. And we're storing all that raw information. And so you can look at any amount of data for a 6-hour window. In this case, I'm looking at over 174,000 different transactions have gone through all my various systems. And sure enough, I can see that there are some error rates. But what I don't necessarily know, again, how persistent is this? What's sort of the common thread? So I'm going to go ahead and actually filter this by front end. And so these are all of the traces that touched a bunch of different services. We can see, for example, this one, it touched the front end, the cart service. Like, these are all the different services that these traces are touching. And then what I want to do is understand that there's obviously some errors here, but what I want to see is this. If I came back to this traces view, we know that it all started from this particular URL. And so what I want to do is see what are also traces that had this same URL, because that's going to give me an idea of how prevalent or persistent is this. Is it every attempt to check out causes a problem, or was there something unique to this? So coming back to this traces view, you can actually group by a metric. That name value pair, this again is that structured log that the structured data that's in your logs kind of get pulled out into traces. These are our name value pairs. We're actually storing, this is the tag, it's a URL, and then here's the value. And so what I can do over here is say, hey, I want to actually group all the traces by the URL. So this is going to show me all of the traces that took place during this time and the distinct value that the URL had. And what this is going to show me is that, hey, this is the URL we were talking about. It looks to be not every trace is failing, but a lot of the traces. Over half of all of the traces that went through all these services and was talking to this URL had an error. So I can go ahead and say, show me my traces that are filtered to this view. And so this is only going to be traces that have that particular, oh, here we go. there. These are only traces that are we've grouped by the URL and only showing me things that are filtered to that one URL that we wanted to see. And so we can see, yeah, this is actually fairly prevalent. Like we said, about 2/3 of all of the traces through this failed. But what's really cool about this view is that now I can also see what a trace is supposed to look like. So this was a trace, again, that went through our checkout system, talked to our payment system. Again, this is the same thing as touching all these services we saw over here in sort of our service map. So these are all the things that it touches. This is what a good trace looks like. We know what the values are, and we can compare this now with a bad trace, and we can see, okay, what's different between this good trace and the bad trace? So we can sort of understand and now compare and much more quickly resolve a problem. The other kind of use case I wanted to show here was great. We've identified that here's an error, and this is a tag that it doesn't matter whether we sort of indexed this tag so it's faster to search for. Like I said, we build this view by actually going back to the raw data and importing it in. So you can sort of react and explore as you want without having to, like build indexes or for people with experience with SQL. It would be like running a query on a table with columns that haven't been indexed. You can do that. You don't have to build an index before. That's the really cool thing about Trace Analyzer and our no sampling approach. But the other thing I wanted to show you by coming back to here where we've done a group by is not only can I see that this is the one we were originally caring about, it's about 2/3 of them are failing. We also can come over here and find some other cohorts. We can see that, wow, you know what? This not only is this URL having a problem, but we can see that this checkout charging one is also about 50% of it ones are failing. Same thing here, same thing here. And so now I can go ahead and explore, okay, let me understand what's actually happening when we filter to this view. And so now I'm seeing this is another value that the tag took on. I'm no longer looking at that checkout URL. I'm looking at a different URL. But again, I can now see sort of cohort traces that are also exhibiting errors. And so this really augments the types of troubleshooting that you can do. Because instead of just getting sort of a support escalation that said, hey, Roberta had a problem, we've been able to elevate our analysis. We've been able to go ahead and say, well, let me understand what's going on with this service and whether those errors are correlated with particular values that these things take on. Now, I happen to use URL, but maybe it's related to a tag like a policy ID or a deployment ID, a cluster name, a particular class of service. That's the great thing about taking all that stuff from sort of Splunk core and your unstructured logs and adding structured data. With Trace Analyzer, now you can start to query and filter by those values and really understand how error rates correlate with these different tag values, and then do further exploration. So I am going to go ahead and stop my share, and we should be back in the demo. Great. So just a couple of key takeaways. So the thing you can do with Trace Analyzer that you couldn't do before is it's a lot easier now to view all of these traces and tags over these larger windows because we've optimized our system. Before we used to have a limit of about 1,000 traces, but now because we're going all the way back to the raw data that we're capturing, we essentially allow you to look at all of the traces and tags. You don't have to worry about indexing things ahead of time. There are aspects of the Splunk Observability Suite where if by indexing you can get faster graphs, you can alert on particular metrics, you can still do that, but this actually enables you to sort of have unlimited, unbound sort of exploration. It's easier to find those related traces. We saw this is critical because when you're troubleshooting, you want to see both a positive and a negative examples. That's going to accelerate your troubleshooting. And really, it's Splunk's approach to traces by not sampling the data, not only collecting certain amounts of information that make this experience possible. I'm going to hop in the chat to answer some questions, but with that, I'm going to hand it over to Z to talk to you about our amazing metrics pipeline. Z?
Thank you, Bill. Hi, everyone. This is Zongjie here. I also go with Z, so from the toughest name to pronounce to the coolest name. So today I'm going to talk about metrics pipeline management that you can get from Splunk Infrastructure Monitoring, a really cool new feature that we introduced in Splunk Infrastructure Monitoring. What we also observed is while we're a data company, we want to make sure we get more data and we want to make sure you actually, as a customer, getting more data for observability and helps you to reduce the my MTTR and MTTD. We do also notice as a number of metric time series, as the data goes up, it's not always mean better outcomes. As the data volume goes up, sometimes you're seeing a diminishing return because different data have different value. The question that we want to help our customer address is, how do I build a cost-efficient observability solution? How can I meet my performance at scale? How can I improve my operational efficiency? How can I make this just a better experience overall from an ROI perspective? And that's why we introduced a really cool feature that I'm going to go talk about after I introduce the really important question here. Why a lot of people are seeing their number of metric time series goes up. A key reason that drives that is something called metrics cardinality. Whenever there is more endpoints of your metric, like a metric name called demo translatency, that's a metric name. But when you have more endpoints, when you have more region, those, or even more like user ID or transaction ID, each one of those combination is a unique metric time series. The combination of a metrics name with the individual endpoints, the regions, give you a unique metric time series. They're the individual person that are living, or individual metric time series that are living in this county, in this city, in this specific house, right? Those combinations give you specific unique time series. And the more of those endpoints we have, the more cardinality we're talking about. And today, with the infrastructure and the services goes more into the microservice environment, with more and more customers going into cloud native architectures, we're seeing an explosion of cardinalities. Instead of 10 endpoints on 5 services on 100 VMs, which gave you 5,000 MTSs, we might be talking about the same 10 endpoint and 5 services on 10,000 containers that gives you 5 million metric years. And it's not just containers, right? Sometimes as a financial service companies, you probably care about the user ID, or any kind of customer-facing companies, you have a critical dimension called user ID or a dimension called transaction ID that actually lock down the numbers by those different dimension values. As a result, you're seeing explosion of metric time series, explosion of data. But we're here to help you monitor environment in a very efficient way and not to worry about the huge explosion of the metrics data. So this is why we introduced really important capabilities, 2 that we introduced recently. One is what we call a detailed MTS creation usage analysis report. And one is a metrics pipeline management, which is critical aggregation filtering capabilities. So what does the first one do? The first one is a report that can actually show you, we already give customer a lot of like usage report, but this one is on top of those usage report. It actually gives you a really important information, a detailed information on how your metric time series and your metrics are being used in the platform. What is the cardinality of that metric time series? What are different dimensions? And more importantly, are those metric time series being viewed in a chart or being used in the detectors? Are you actually using those metric time series? Because with those information, you can actually identify metrics that are not used efficiently and potentially can be aggregated or even dropped out of the system. So how would you do that? Let's say you have those top metric time series that you have identified. Wow, those naughty metric time series, it's time to do some optimization on you. We offer the tool called metrics pipeline management, where you can do in product, very easy in product UI that you can centrally manage the rule on those metric time series for aggregation, basically aggregating the data, dropping certain dimensions. For example, I wouldn't care about things at a user ID level when I monitor things. I want to aggregate it, latency performance by service, not by user ID. I can aggregate the metrics, drop the user ID dimension, therefore reduce the cardinality and metric time series significantly. Or you can even filter the data out entirely. So when I showed this to customers who are doing preview with us and to new customers, and existing customers, I got a lot of like really amazing positive feedback. Basically, they're like, wow, I just love how as a vendor, you actually come and tell me how I can optimize the usage and reduce the cost on you. Well, for us is we want to give you the best value, right? We believe data are of the same value. We want you to have optimized performance and cost experience with us. That's why we introduced that. So I'm going to give you a quick kind of a little bit of more detailed view, and I'm going to show that in a demo as well. This is what a report looks like today. Today is Excel-based report that actually shows metrics names, shows the cardinality, the dimension values, and whether it's used in a detector or chart. Currently, it is on-demand report that you as a customer can ask via support ticket, a swap ticket to generate that. We are working on making that in product. It's going to really make it easy for you where you can ask that in the product. So that is what the report is. It's called Metrics Usage Analytics Report. I wanted to show you some really interesting, actually examples of takeaways you can get from that user report so you can see why it is super helpful. This is the example from one of, well, of course, I sanitized that from some of our customers' usage. This is the example, right? So this customer have a total of 2.6 billion metric time series created over the past 30 days from 1.1 million unique metrics names. That's a lot of metrics names. Each metrics names is literally just the metrics name, right? CPU.utilization or job.started.count. So they have 1.1 million metrics names. What is really interesting when we look at the report is 50% of the metric time series created are actually coming from less than 200 of those metric time series. So if you wanted to optimize your metric usage, you don't have to go into 1.1 million metric names. You just address the top 200, you will see a significant impact. And within those top 175 metrics names, we noticed for this customer that about 20% of metric time series are represented by 43 metric names are not used in any detectors or viewed in the chart over the past 30 days. So nobody is looking at that metric time series, a metric name. Nobody is actually alerting on that. And those really should be routed to a low cost tier, or they should be actually filtered out because nobody is using that. We have also among those 78 metrics names, there are 100 of them, which represent 31% of the metrics time series generated, are only viewed in the chart but not using detectors. And when they're only viewed in the chart, a lot of the time, as you and I know, we don't look at 30,000 lines in a chart. We look at it in a very aggregated way. So the question is, do I actually need all the detail levels, or should I just aggregate them and looking at them at a service level? Instead of grouping by in the chart, I could potentially just aggregate it as the data come in. So overall, about 50% of those metric time series could actually be optimized among the 1.1 million unique metric names or 2.6 billion metric time series. So this is really just an example to show how impactful that report could be, where you can take actions and the potential impact of your usage could be 20% or even up to 55% or even more. So this is what it looks like in the product. This is really in the UI, and I'm not going to spend too much time here because I'm actually going to go to a demo to show you how you can use that in a product. So I'm going to start sharing my screen. Okay. So I will start by showing this sample report. This is from our demo environment. So as you can see, it lists out the metrics names. It lists out the metric time series that was generated over the past 30 days. The number is not that big because this is just our demo environment. For our customers, we see a much higher number of MTS count here. We're talking about sometimes even millions. But as you can see, this metric called job start event, well, nobody has viewed that over the past 30 days, and there's no detector tied to this metric name. I can also see that there is the dimension that are commonly used here And one of the dimension, which is job ID, are actually having a lot of cardinality there. There was a huge, like 21,000 different values of the job ID over the past 30 days. So let's take this as example and go into our platform to see how I can potentially aggregate or even job this metric. So I'm going to copy the name.
Just so you know, we only see a spreadsheet right now.
Yes, I'm going to go. Thank you.
Okay.
I'm going to go to the platform right now. I'm trying to show the report, but I'm going to go to the platform right now. So I copy paste. Thank you, Billy. Please do let me know if you don't see my our demo environment right now. Can you see my demo environment right now?
Yep, you're good.
Okay, cool. So in order to do metrics pipeline management, you go to settings, as I did, and then you go to metrics pipeline management. When you go here, you can see that there's a lot of rules that are already set up by my colleagues. So future your colleagues will be setting up rules, and you can see those rules for aggregation and filtering. And let's start by creating a new rule. So I'm going to create a new rule for this new metrics name called job start events. So this is the new metrics name. And so give me one sec. Oh, I just typoed on something wrong. So with this metrics name, I click OK. I can see that, well, job start event, the current volume for this metric time series is 3,700 MTSs. Well, not a lot because this is the demo environment, as I mentioned. In your environment, you might see some metrics that has a lot more metrics time series tied to that. So what I can do first is add an aggregation rule. So in aggregation rule, I can choose to filter down the job start events by certain dimensions. So I only narrow down to certain population of the metric time series to apply the aggregation. But for now, I'm just going to go actually apply it to the entire metric. So I'm not going to add any filter. A really important information I can see here is all the different dimensions. And as I mentioned earlier, job ID is a dimension that really create a lot of cardinalities. You see that right now, as of now, in my active metric time series, which I look back over the past 24 hours, there's already 754 values of the job ID. In the report that you see earlier, we see higher numbers. That's because it was looking back over the past 30 days. We want to make sure, like, you know, over the past 30 days, whether a metric is being used or not. But clear, this is where most of the cardinalities come from. So what I can do is I can choose to keep certain dimensions. Like, for example, if I care about the Azure Resource ID, if I care about the aggregation type, I can choose to keep those dimensions, or I have a clear understanding of the dimension that I want to job. And that's what I'm going to do here. I wanted to job ID. What will that impact be? Well, that impact is we in our system is going to create aggregated metrics by aggregating data along the other dimensions and job this dimension. That means if I refresh it, you can see that instead of 307,040 metric time series, we're actually adding 5 more metric time series called aggregated metric time series. And you might be wondering, well, aren't you telling us that we can actually reduce costs? Why are we adding more? Well, that's because those are the aggregated metrics that we generated, where you can give it a name. We can help you aggregate it, create a name for that, and you can add this as aggregated metrics. And what you could do next is, well, I think this aggregated metrics without job ID is good enough for me for monitoring. I do not need the job ID information. So what you could do is to decide to drop the data that are actually the raw data that contains all the job IDs. One thing that we do build in for our customers is to make sure you are actually modifying any chart or detectors that are already using this metrics. Add the new aggregated metrics name in to make sure that you don't actually drop the data without adding the new one. You don't lose your visibility. So what you could do after seeing that warning, like, oh yes, I need to remember that I have to actually modify the chart. So you can go here and you will be able to see the related chart and detectors. If you click on this, you can see the related chart and detectors listed here. Of course, with the job start events that we just selected, it doesn't have any detector and chart using that. So I feel pretty comfortable of dropping that right now. I'll be able to show you later like how it looks for a metrics that actually have chart and detector. But for now, for this one, I feel pretty comfortable. I could even choose to drop the entire thing without any aggregation, but I feel like, yeah, someone on my team may actually, or maybe in the future, I might still need to use this metrics, but looking at it at an aggregation type level. So that's what I'm going to do. I'm going to drop the job ID, and then I'm going to drop the raw data. I'm going to enable that. And what you would see here is the metric volume was 3,740. I add 5 aggregated metrics, and I dropped the original 3,700 metric time series. So net, I'm actually only having 5 metric time series. So I significantly reduced the cardinality and reduced the number of metric time series for this specific metric. So when I save that, this is the result, and I confirm, then you can see, oh, I have a new rule that I created here that actually have both an aggregation rule and a data drop rule. And this is the rule that I just created. And you can, of course, try to add it or delete it if you don't want to have this rule anymore. So another example I just quickly wanted to show is the CPU utilization is another rule that my colleague has created. So CPU utilization is a pretty common metric time series, right? So you can see that metric name. So you can see that this is actually being used in chart and detector. So just give it a little bit time to fetch the chart and detectors in the system. As you can see, it is actually the raw metrics are being used in this chart and in those detectors. So what you could do is go into that chart or detectors and actually add a new metrics name, which is the aggregated metrics name underneath that. So creating a new metrics, use the new metrics name. And then if you do that, when you drop the data, raw data, you will not going to lose your visibility into the charts. So that is what my metrics pipeline management function is. I'm going to stop sharing. I might stop sharing right now. And I know my colleague has been answering questions on the side already, and I'll be answering more questions. And this is a really exciting feature, and I encourage you to explore that. It's available in your environment already. So I'm encourage you to use that and reach out to us for any questions and feedbacks. I will pass it down to Jill to go talk about another exciting feature that we're releasing. Jill?
Thanks so much, Yee. Really appreciate the demo there. So I'm really excited to talk to you all about Incident Intelligence, which is our on-call incident response solution that we just launched just about a month ago in the Observability suite. When we think of the top incident management challenges and what's really driving chaos and staff burnout, we really think about preventing unplanned downtime. So leading observability orgs, they tend to have 10% less outage costs per year when they have an incident response solution in place. And they don't overwhelm their teams with a flood of alerts that don't have the proper context for them to get started on incidents. And when all of these incidents are pouring into an organization, we feel that we've seen a lot of teams have fragmented communication lines, and it's really difficult for them to unify their collaboration mechanisms, which is why incident response was one of the tools we really wanted to bring people together with and help them solve problems in a very collaborative fashion. And lastly, just accelerating mean time to resolve for incidents. This is really automating as much as possible, having the ability to kick off different tickets on ITSM tools, just like ServiceNow or Jira. We want to make all of the boring stuff as automated as possible so that responders that jump into the platform can really just get started initially. So here's a view of just the typical incident lifecycle. So a knock notices a problem, sends out an alert, someone gets paged on their phone, that page may be act, and then there is a number of people who might get involved, Slack messages that are started, maybe a Zoom meeting room is fired up, And then eventually maybe some code is deployed and finally that service is restored. So this can take anywhere from like 6 hours, include about 5 different reroutes to different people across like sometimes even 8 people who might have been involved in that single incident. Which is why, just to kind of close the loop on all of the amazing things you guys have heard about today, we wanted to incorporate an incident response solution directly into the observability tools that some of you have had the pleasure of experiencing with our Splunk Observability Suite. So incident response is now a first-class citizen alongside our other tools like infrastructure monitoring, APM, log analytics, as well as synthetics. So we're really excited that incident response is now available for your observability suite. And the things that we're trying to do within incident intelligence is take all of the alerts that are triggered not only across Splunk, so Splunk Enterprise or observability, but third-party alerts as well, and then group those alerts for you so that we can create less notification noise to your downstream on-call users, and then provide a platform where you can easily collaborate with your team members to solve problems and essentially resolve those incidents. So incident intelligence, again, here's a preview of our tool. We have a team-based incident response solution where we allow users to group alerts just to reduce the amount of noise that gets triggered on the notification end. We allow you to integrate different chat ops like Slack, as well as ITSM tools like ServiceNow or Jira. And then we have integration with Splunk Observability and the mobile app. So if you're on the go, all of these capabilities are now offered directly in your pocket. You can acknowledge, reject, resolve incidents straight from your phone. And when it comes to the time where you actually have to jump into a console, you can have that switch off and immediately go into troubleshooting an incident. And because this solution is built directly in the observability platform, you have all of the capabilities that Z and Billy were showing you previously across the entire observability suite. So you have all of the different perspectives to look at data across APM, IMM, RUM, synthetics, whatever it may be. We are grouping these alerts for you in order to make it easier to get started in the troubleshooting journey. So now I'll go ahead and jump into a demo. So here you see we have a list of incidents that have triggered. I'm currently on call, and I will jump into one of these incidents. Here I'm able to acknowledge the incident. I'm also able to do a few different things. Like I can resolve an incident, I can snooze an incident if it's something that I want to get back to later. And I can also just dismiss an incident if I don't think it's an actual issue. I also have the ability to add different collaboration tools. I can add Slack channels, I can fire up a Zoom meeting. I can also add different resources so that if other people jump into this and they want to see what actions have been taken, they can see that maybe a Jira ticket was created or a ServiceNow ticket, and all of that information.
We're not seeing the screen. Yeah. We're not seeing the slides.
Let me try that again.
Yes, we can see it now.
Okay, perfect.
Lost again. Yeah, we're good.
Okay, great. So this is my incident dashboard where I can see all of the incidents that have been triggered. I can jump into a specific incident and I can take all of the different operations on this incident from acknowledge, resolve, snooze, or dismiss. Right now, I'll just acknowledge this incident. I can see all of the responders that are related to this incident, and I also have the ability to add different responders. So I can go ahead and add Venkat to this. Save. Now Venkat will get paged, and he can join in our collaboration to resolve this incident. Again, one of the primary reasons we wanted to build incident intelligence within the observability suite was to expedite the troubleshooting journey. So Now, any alert that gets correlated with an incident, we have the ability to troubleshoot across the observability suite, and we would provide all of these direct links that will take you across the rest of the observability platform. So this is really just meant to streamline your experience with the entire observability suite and make it easier to resolve incidents faster. And when we create incidents, we have the ability to determine which incidents are routed to a specific service. So in my example here, I have my backend services where I can pick different alerts that I want to be associated with my service, and I get a preview of all of those corresponding alerts. This flexibility allows me to drill into the raw metadata of all of the alerts that I'm managing for my team and for my given service, and I can clue into the exact key value pair of filters that match a specific payload from an alert. So I can have the finest granularity, or I can be as general as possible. And then I have the option to preview all of those things that are associated with my given alerts. When it comes to grouping, I also have the ability to ensure that every time an incident gets triggered, I don't have multiple alerts get triggered with it. So this is where I can determine when an incident should break into another incident and a previous incident should close. So essentially, this pause configuration allows me to determine when one incident ends and how long you should wait from not hearing another alert for another incident to trigger and kick off. And lastly, I can define a workflow where I can add users to immediately get notified. I can add different collaboration mechanisms like Slack, so I can ensure that a Slack channel gets created right when an incident is triggered. And I could say, hey, check this out. And I can continue to add different responders to the incident so that we can ensure that someone else will triage this incident immediately if I don't acknowledge it within time. And lastly, from an on-call management perspective, we really wanted to give users the ability to create their schedules and allow users to swap shifts with other users. And within these shifts, there's the ability to have an entire follow the sun support, so that we have shifts for our Asia team, our Europe team, and our West Coast team. So this is really our ability to bake in all of the on-call management capabilities within incident intelligence so that users can respond to incidents faster and they can manage their teams who are on call so that they can immediately jump into incidents and resolve any issues with the rest of the observability suite. And now I will pass it off to Patrick to close us off.
Let's close off here just by talking a little bit about the overall strategy here that we have Splunk around observability. Now, I spoke up front about how our platform incorporates first-class capabilities for handling logs, metrics, and traces. And you hopefully saw from these capabilities that we talked about, the parts around traces and metrics. Now we're kind of really advancing the state of the art there, right? And I think that just a really quick recap here is that I think we've built up these capabilities because we think it's necessary to continue offering the core value prop of Splunk, right? That once you have the right foundation of data, you can use it for many purposes, whether that's for your infra and SRE teams, your software engineers, your security teams. Right? And with that foundation, we're able to keep you covered, whether you're modernizing legacy applications or refactoring monoliths, or if you're already using Kubernetes, serverless, microservices, and like. Okay. All right. So with that, I think if you'd like to learn more, I'd encourage you to attend .conf. It's happening later this year in Las Vegas in July. And then let's see, I think we can stay on and answer any questions that are unanswered. But otherwise, thank you very much for taking the time to join us today. I hope you enjoyed it. All right. Let's see. All right, so maybe we'll just do a couple of questions here. Let's see. Does incident intelligence integrate with Splunk Enterprise or Splunk Cloud Alerts? Gio, you want to take that one?
Yeah, sure thing. So incident intelligence does integrate with Splunk Cloud Alerts. We have an app. It's called the Splunk app for incident intelligence. It's available on Splunk base. And when the next release of ITSI drops in June, we'll also be integrating directly with episodes from ITSI.
Awesome. There's also a question about, quite a bit of questions about Trace Analyzer and how to get trace data in. Maybe, Billy, you can just kind of touch on it briefly.
Yes, let me unmute. So I tried to answer a couple of them as spot. The kind of the high level way of saying is the way you get information really into any of our observability practices is through OpenTelemetry, which is sort of a vendor neutral, vendor agnostic, open source instrumentation system. So you can instrument your app and then using and all sorts of libraries are supported everywhere from C++ to even Java, .NET, Ruby, Python, PHP, kind of everything. And that, again, that's the great thing about OpenTelemetry is that it's collecting everything and you're not logged into us. It's not a proprietary agent that you have to install and then you keep using Splunk observability grudgingly. No, we are so awesome that we are using open source stuff that would work with anything, but we know that we're so awesome, you'll continue to use us.
Excellent. Thank you, Billy. And then one last question before we kind of close off here. Can you briefly review the controls we have around filtering the data in metrics pipeline? Z, you want to take that one on?
Yes, so there are a couple of ways of filtering the data. The very easiest way, or the most easiest way is to drop the metrics entirely, right? You could do that in a very easy way. You can also choose to drop certain dimensions. As I showed earlier, you select the dimension you want to drop or select the dimension you want to keep. That means we'll be aggregating on the dimensions that are remaining. You can also do an even more accurate way of filtering out a subsection of that metric, a subsection of the metric time series, and do the full data drop or certain dimension data drop in a more detailed way. So there's a lot of flexibility there. And one thing I didn't get a chance to say is you can do all of those through Terraform as well. So if you're a very heavy Terraform user, you can do it in a very efficient way across many metric time series using Terraform.
Okay. Thank you so much, Z. All right. With that, I know we're a little bit over, so I will end it now. If we didn't get to your question, we will email you with the answer. But again, thank you everyone for your time and attention today. I hope it was informative, and we'll look forward to speaking to you soon and hopefully see you at Conf as well. Okay. Bye-bye now.